Well, welcome to our kickoff seminar for the College of Design, Construction, and Planning 2024 Research Seminar Series. And who better to start this series than Shenhao Wang? He is a dynamo, if any of you have crossed paths with him. He's an assistant professor and director of the Urban and Artificial Intelligence Laboratory at the university. And he has been really instrumental at trying to move, the urban analytics master's program into reality. He has really hit the ground running in terms of developing his whole research program. And I know many of you might have been made aware that he was a 2023 recipient of the University of Florida's ROSF seed program, which is very, very competitive. I know some of you in the audience are interested in applying for that. So he'll be here to, give you a little guidance, and that's the project that he's talking about today. We also have Lisa Platt in the audience. She's going to help field some questions with me, and she has moderated many of the sessions for the research seminar series this year. And she was also one of the other recent recipients of the ROSF for a project, a patent that she had gotten that she was taking further. So Shenhao, his research thus far has been funded by the Department of Energy, the Singapore MIT Alliance for Research and Technology. He's also gotten other industry sponsorship. Dr. Wang completed his interdisciplinary PhD in computer and urban science at MIT recently. At his BA is in economics from Peking University, and also has degrees in architecture and law. And we're very happy to have him here. You're in your second year, right, at the University of Florida, and we're glad to see how the research is taking hold. Outside of the academy, you can find him on the soccer field, where he actually plays in a league here in Gainesville. So let me turn the program over to Shenhao, who's going to be talking a little bit about his research study that he has gotten sponsorship through the University of Florida. Thank you.
All right, and thank you, Meg. Let me start to share the screen for the audience. So Meg, just a double check. I have about like 30 to 40 minutes for presentation and about 20 minutes for the Q&A. Is that right?
That'd be perfect. Yep.
Okay. So Meg, the Zoom says that the host disabled screen sharing. So could you enable the screen sharing? Meg, so I cannot share my screen at the
Try now. Try now.
You should be able to now.
I could do it. Okay. Okay, good. Could you all see my screen?
Yes.
All right. Thank you, Lisa. All right. Thank you, everyone. I'm very excited to share my research and projects with you guys. As you can see, the topic today is about urban artificial intelligence. So for today, this is the outline. I plan to present about 4 parts. At the beginning, I just give you a short introduction to my lab, Urban AI Lab, the UFL. And then I'll spend about, I think, 20 minutes to introduce the research, the urban AI for three topics: individual choice, spatial-temporal dynamics, and the social norms. And the third part, I'll talk about the social impact of my research, mainly the DOE and the new Singapore M3S project. Unfortunately, I do not have the room to discuss the UF seed grant, that project, but I'm happy to answer a question about winning the seed grant in the Q&A session. And last one, I feel like today is a great opportunity for me to do a bit advertisement for urban analytics, both my class and the new master program. All right, so this is just the 4 parts for today. So my lab, Urban AI Lab at UFL. And so you could find the details of that lab in this following URL, the urbanailab.com. And I also put the QR code here, just to facilitate you guys to access the website from just scanning it on your iPhone. And the lab is an overarching question is that how to integrate human and machine intelligence for the future cities. I understand this question looks very abstract, but when you think deeper, a lot of specific questions are actually about this overarching question. For example, we often criticize that deep learning is a black box model, and the question becomes how to interpret it for our urban practice. And then people often ask the question, AI might replace human jobs, like planning jobs. And if we reframe the question, it becomes, could a human and a machine really collaborate for a higher productivity? And meanwhile, we also know that all the machine intelligence and the human intelligence, we have the social biases. So here the question becomes, could we leverage a machine intelligence to mitigate such social biases? So in my work, there are 3 themes: the urban AI for individual choices, and urban AI for spatial temporal dynamics, and urban AI for social norms. So the first 2 are on the positive theory side. The first one analyze using the deep learning to understand the individual behavior, particularly how people make a choice. And second, still use the deep learning to capture the spatial temporal dynamics and design the model called deep network models to capture such dynamic. And third one, which is different from the first 2 topics, because it is on the normative side, try to use the deep learning architecture and the general AI techniques to understand social norms. So a small note here is that whenever I use AI, this very general term, it refers specifically to the deep learning technology. Then in terms of urban application, I mainly work on the urban mobility field. But all the discussions today are very general. They could be applied to other applications as well. All right. So shared by all these topics, wait a second. Shared by those topics, there are 2 recurring themes in my research. One is about the data. I think I already presented the GLIM framework, graph language imaging number, the framework in a few settings. So today I will not elaborate on that. And the second recurring theme is on the model side. I call it integrative human machine intelligence. But for today, I just want to just introduce some recent progress on the 3 topics, and will not discuss too much on the 2 recurring themes. So let's go to the research part, the urban AI for the individual choices. The leading question for this research theme is how to use the deep learning to analyze individual choices. So I started this work back in around 2018. At the moment, was just a collaboration within MIT, but 6 years later, has been really a worldwide collaboration on this research theme. Just a very quick background about the individual decision in the urban context. So here is just an example about the classical travel mode choice. An individual, the person, you should choose between 2 travel modes. One could be automobile, a second could be the public transit. Typically, as you know, automobile is more expensive, or like Uber, ride sharing, those things are more expensive, but they are typically faster. But for the public transit, it is much cheaper, but usually it takes a longer time. So for this individual choice, we try to understand the trade-off between this dollar value and the time value, and predict how individuals make a decision between these 2 alternatives. This simple question actually has a very broad implication in the urban settings. I just gave you an example about the travel mode choice, but when you think about the urban context, like you could see a lot of such applications. For example, beyond the travel mode choice, we look at the Uber app. You always need to choose between the single passenger trip or the ride sharing. Or when you think about your long-term decision about your location, residential location or job location, it is also a choice analysis. It's just that in the spatial setting, you have a much complex a spatial alternative set, but it's still fundamentally is individual choice analysis. And then you could also think about individual choices for the automobile ownership decision, trip purpose decision, or travel route decision. So very broad applications in urban setting. One specific research I want to introduce today is a recent published work. It's called a deep hybrid model with a satellite image. The leading question is how to combine the demand modeling and the computer vision for the behavior analysis, or specifically individual choice analysis. So this is a collaborative work with the MIT team and the professors from UC Berkeley. So first, you may ask, why do we try to integrate social demographics and urban images? There are at least two reasons. One is imagery is really ubiquitous in all the human decisions. So for example, when we think about the driver decisions, like drive or change lanes, of course, we could capture such decisions by using the driver's social demographic background. But when we really think about the decision setting, it's always a street view image, or let's call it street view, a video that change driver's decisions. And it is the same thing for the consumer decisions. We could capture such a decision by analyzing the social demographic background or the price factor of the consumption goods. But when we really think about the decision setting, those images really change people's decision. The second reason is those urban images actually has a social economic values. There's an old quote saying a picture is worth 1,000 words. And actually, since we work on the urban planning setting, we have been discussing such a social benefits of images in the planning setting for many decades. So we should not be unfamiliar with this idea. So this is the question, how to integrate the numerical data and urban imagery for individual decision analysis, improving both prediction and interpretation. There are two highlights I want to discuss today. One is the integration of the two data structures. And the second is that we could actually generate new urban imageries for economic interpretation. This is just the framework of a deep hybrid model. I summarize it as a crossing structure. So just intuitively, you have the vertical axis and the horizontal axis. So those vertical axis kind of resembles the classical discrete charts model of regressions, but the horizontal axis is more on the deep learning and the computer vision side. By combining them through the latent space, we could get the kind of synergize the two frameworks and get the benefits from the both sides. So let's just jump to the findings. One is that this deep hybrid model could integrate the data and the models. So here is just empirical finding. Each row represents one output or dependent variable, and each column here represents the modeling approach. So we use a classical approach, the pure theory-based approach, or deep learning approach, and the last column is the deep hybrid model, this combined human-machine intelligence approach. And as you can see, our deep hybrid model approach could outperform both the traditional classical approach and the pure deep learning models. So that's just demonstrate the power of this integrative deep hybrid model framework. But the second is we could use this deep hybrid model to generate new urban images for economic interpretation. So here I just show you a line of images, which is actually 6 images. So the left-hand side and right-hand side, there's the kind of existing images. But in the middle, all the 4 images are generated images. But when you look at the images, they look very real. And more than just generating this new realistic images, we could even tell a social economic story for each urban landscape. For example, we could compute the market share of the different travel modes related to those new urban landscapes. And here, just zoom in to those regenerated images. So we could just ask the machine to say, okay, generate some downtown image for Chicago area. This is the first image. And the second one is we generate some suburban landscape for the Chicago area. This is the second image. As you can see, these two images are of relatively high quality. So for this line of deep choice models, actually there are a lot of work. For today, because of time limit, I could only present this deep hybrid model with data image. These are recent publications. This work is really built upon a lot of past published work and related to many ongoing work. So here I just present like other 5 published work. Like each one has its specific focus, like on the economic interpretation, architecture design, synergy of different modeling frameworks, or its underlying static learning theory, or how to combine review and stated preference to understand the adoption of autonomous vehicles. For other research, I have to skip them today, but I'm happy to answer questions if you have that. The second research topic is urban AI for spatial-temporal dynamics. The leading question is how to use those spatial-temporal deep learning to analyze urban dynamics. But I guess many audience may not understand, like very familiar with the keyword spatial-temporal urban dynamic. So I would like to use one example to answer what is spatial-temporal urban dynamics. Here, the visualization just shows spatial-temporal transit ridership in a Chicago area. So each image is actually a map of the West Loop area in Chicago. So this node, these circles, represent the transit ridership at a different time. So you can see there are 4 images that represent the 4 kind of spatial visualization of the transit ridership at 4 time points in Chicago area. So when you look at this image, the whole visualization, you could see immediately there are 3 dimensions. To describe space, you need 2 dimensions, right? Like longitude, latitude. And then to describe time, you need to have 1 extra dimension. So that's why when people analyze the spatial-temporal urban dynamics, the data structure is always called a 3D tensor because you have 2D on the space side and 1D on the temporal side. So combine them is just a 3D spatial-temporal analysis. A very quick side note, many of you might be familiar with TensorFlow, right? It's a product from Google, and whenever they use the term tensor, it kind of refers to a 3D tensor. So which means this Google TensorFlow is really naturally designed to understand urban dynamics. This spatial-temporal dynamics could be analyzed through the deep learning framework. Typically, we just need to combine the graph models and the temporal models. So here, I just present you the 3 deep learning architectures from other research articles. I will skip all the detail here, but when you look into those visualization, you could find those kind of spatial information, some models to process the spatial information, and some models to process the temporal information. And in the end, they somehow combine those information in their final model and do the prediction task. There's a research gap in the current work, which is most of such spatial-temporal deep learning models only focus on the deterministic prediction. But we know that a lot of urban phenomena are quite uncertain. That's why my work, which I present in the next 3 slides, will focus on the uncertainty quantification of such spatial-temporal dynamics in cities. So the first paper I work on is called uncertainty quantification of spatial-temporal travel demand with probabilistic graph neural networks. So when you think about travel demand, first of all, it always has a spatial-temporal dimension because people, or you think about the specific rider, right? He wants to use the, let's say, public transit. This needs are always embedded in a spatial and a temporal context. But we also know such travel demand is uncertain. So we want to quantify such uncertainty in the travel demand. In terms of technology innovation, in this work, we propose a new framework called a probabilistic graph convolutional neural networks, as opposed to those deterministic graph convolutional neural networks. And then we apply this framework to quantify the demand uncertainty. And we found that with this new framework, we could improve the performance by at least 25 percentage points. So this one is still under review in IEEE ITS, but here is a QR code. You could check the archive version of the paper. So here is just visualization for the spatial temporal deep learning model. So here is the very short formula for our model. So the F is the deterministic part and the G is the probabilistic part. When we combine G and the F, also show here in this visualization, this deterministic architecture and probabilistic assumptions, we could do this. We could quantify the uncertainty in the travel demand. Another paper we kind of built upon the previous one is we try to quantify the uncertainty in the sparse travel demand. So in a lot of cases, our data set are very sparse because as in the spatial temporal setting, we cannot observe all the data points for any time and in any place. So we need to deal with a lot of zeros in our data set. That's why we designed a model called Spatial-temporal zero-inflated negative binomial, GCN, to address such sparsity. And it's kind of a general tool and could address any the prevalent data sparsity issue, not only in the urban mobility. So this paper is published in the ACM-KTD, which is a leading data mining conference, and you can find the paper here. Yeah, I'll skip the visualization, but when you look at it, actually it's very similar to the previous one. We have a deterministic part, but also the probabilistic assumptions. By combining them, we could capture the uncertainty in such sparse travel demand. So I did not try to delve into the mathematical details, but my point is, if before my presentation, you may ask a question, what is a 3D spatial temporal dynamic? But I hope now the question becomes, what is not a 3D spatial temporal dynamics in an urban setting? Because when you think about any topic in cities, like the energy, air pollution, ridership, accident, or safety, or anything, it's always have this 3D spatial temporal dynamics, right? Like energy consumption of the building. Any building is embedded in the spatial context, so it has a first two-dimensional, and then that energy consumption always evolves over time. So it also has a third dimension. Air pollution, the same thing. Transit, ridership, accident, they are all very similar. So that's why, like here, I just say I try to seek more collaborations on all those fronts. I could provide those three-dimensional modeling techniques and want to work with more like domain-specific experts and then work on exciting research projects. So the third theme in my research is urban AI for social norms. The leading question is, what are the potential algorithm biases in models and data? That's why we just work on the paper called Equality of Opportunity in Travel Behavior Prediction. Essentially, we try to quantify this kind of classical qualitative notion, equality of opportunity, and understand the prediction biases in the travel behavior prediction. There are two major findings. One, we find that prediction disparity really widely exists. So we examine the 4 dimensions: high versus low income communities, racial majority versus minorities, urban versus suburban regions, and male with females. And we also find that those disadvantaged groups tend to have higher prediction errors. But it's not just a bad news. We could also design new algorithms to mitigate such prediction disparity. So I'll skip the detail here, but if we modify the object function by combining the prediction accuracy and prediction disparity, we could balance these 2 parts and then mitigate the prediction disparity between the advantage and the disadvantage groups. We could also adopt this approach to analyze spatial segregation. So recently, we just published a new article called Fairness Enhancing Deep Learning for Ride-Hailing Demand Prediction in the Chicago context. Very quickly, we found that if we start our bias mitigation approach, we could see a lot of prediction errors and also kind of clustered prediction error here, like in the southern Chicago area. But with our bias mitigation approaches, we could reduce this kind of clustered or segregated errors for the southern Chicago area. It is still an ongoing work because we understand such algorithm biases exist, but we still don't know exactly what are the root causes for such biases. It could come from the human input, like the data, or could come from the machine process. All right, let me go to the third part, the social impacts of our research, because what I present are on the research side, and a lot of them are quite fundamental and methodological. So here I just quickly introduce two projects, the US DOE project and the recent Singapore NRF project, to talk about the social impacts we have and a very broad collaboration. So for the DOE project, the topic is the smart transit-centric multimodal system design. It's lasted for about 4 years, and then this year is the last year project. So here's a diagram for the project goals. Basically, we use the 3 leading AI techniques, robust optimization, reinforcement learning, and deep learning, and build a smart transit system. We want to make innovations in terms of technology, in terms of system, and the social impacts. So on the right-hand side, this is our collaboration network. Visualize how we allocate the task for each partner. I mainly lead the University of Florida, our team, and working on the demand prediction, data system integration, and the pilot experiments. But we also collaborate with other teams, Northeastern University, National Renewable Energy Lab, MIT, and the industry partner like Chicago Transit Authority. One achievement I want to highlight is that we successfully finished a field experiment, a pilot experiment last year in collaboration with the Chicago Transit Authority and the DOE. So there are a couple of things we did there. One is that we built a real-time control dashboard to streamline the bus control information. And with our control dashboard, we also implemented an AI-empowered recommendation engine to control the bus dispatching. And in that pilot, we also demonstrate a significant achievement by reducing waiting time for 37% and also reduce overcrowding by 10%. So those are very significant achievements, because by achieving those things, we did not ask for any extra resource. All right, we just implement new algorithm, so which the cost to the agency is nearly zero. So here is just a bit more context about the pilot. We focus on one bus route, which is Route 81. We implement our terminal control in the Jefferson part, and the technology is mainly the RL technology, analyze the dynamics between the bus and the bus drivers. Here are just pictures about our students working on the site to dispatch the buses. Last part, I just want to do a bit advertisement for the urban analytics, both my class and the Master of Science in Urban Analytics, our new. That's all about my presentation today. So there are 4 parts: the lab, research, social impact, and the urban analytics. And then if you are interested in getting involved in my lab or research project, or you are interested in our ongoing research projects or my class and the program, just feel free to contact me. Yeah, thank you very much.
Thank you so much, Shenhao, for a really interesting, fascinating presentation. Just as a reminder, we are fielding the chat for any questions you might have for Dr. Wang. So if you have them, go ahead and either type them in the chat or raise your hand and unmute yourself, and Shenhao can ask or answer your question. Shenhao, you touched on this a little bit in your presentation already, but where do you see specifically the outcomes of your funded research being used at 5 years from now, in terms of what kind of future facing effort do you see this particular research being contributory towards?
Wait a second, I'm still adjusting. So, Lisa, could you still see the screen on my side? No,
no, it went black.
Oh, okay. Yeah, sorry, I was paying attention to some the slide issue there. Yeah, so to clarify the question, so you're asking the social impacts of the work.
Yeah, the social impacts, or really the future benefits of this particular research, looking like 3 to 5 years down the line. where do you see this research evolving towards, or do you see it, contributing to a specific aspect of the work you're doing now in a more meaningful or cogent way?
Yeah, thank you, Lisa. So the question is actually exact about my third part, the social impacts of the work, right? So it could be a kind of really narrow social impact, but also very broad. I could just use the M3S, the Singapore project, as an example. In a narrow sense, we try to work with the communities, local communities, and develop tools that they could use and help their life. So I say it in a very broad sense, right? But like one example is we try to use the algorithm, like reinforcement learning algorithm, to understand how people make the career decisions. Right? That's a kind of dynamic decision, right? When you want to go to school and when you want to take this job, when you want to move to other place and then to take another job, right? But people make mistakes in such decisions, right? A common example is that they delay the education forever because education, that's an investment, right? So people, of course, education and the job is just one example, but people make all kinds of mistakes. So we try to use AI to design some dynamic behavior models and recommend their kind of next career decision for them. And especially because we work with the Malay community, those disadvantaged social groups there. So we want to use this tool to help their career growth. And then that's at the career level, but even this dynamic decision perspective is a kind of universal perspective. It could be at a like small scale, and people just dynamically learn some class, right? In one semester, they kind of learn the classes in a sequential way. So we could also recommend the different learning modules for those students, like they're using some online tool like SMU, some online platform in Singapore, and we try to embed our AI models into those tools to help their learning experience, just within one semester. Yeah, that's at a relatively small scale. But meanwhile, we have other components have really national impact. For example, that ethical AI discussion, right? We're all concerned about the fairness issue, the transparency issue, the privacy issue in the model and the data. Right? For example, I talk about the spatial-temporal dynamics, but one data set we use is the phone trajectory data. So whenever I look at the individual level phone trajectory data, I, as a researcher, even get concerned that I could see the person's home location and their job, and maybe even know more than their family about that one person's, spatial and temporal details. So how to design those privacy-preserving algorithms and such a general guideline at the nation level? So that's another major impact for the research.
Thank you. That was a great answer. Okay, we have had a question come in from Bill Odell. Could AI be used to examine local housing planning documents to determine if there is text that results in increased exposure to flood hazard?
I like this question because actually this is to the point of AI. So one unique factor about AI, which differentiates it from all the other quantitative research, is that it could process all the unstructured data, those images, graph, video, voice, and the text, right? So based on this statement, I think it's possible to directly use a planning documents as text as input, and the output is this kind of increased exposure, like some risk in the food hazard, right? So you have the input and output structure, and then because AI enables us to directly or automatically process this text information, so I think it's highly likely you could design such algorithm or model to achieve this goal. In terms of industry, I think there might be some small business that are already working on that. I just talked to some planning director just in Florida. They told me there are some companies try to sell such algorithm to them. And for now, the price is too expensive. They told me it's like $1,000 for one planning document, which is way too expensive for a planning agency, but which at least suggests that such a technology exists, such a startup even exists.
Other questions for Dr. Wang about his research or his recent acquiring of the ROSF grant?
Shenhao, oh, go ahead. Go ahead, Ivy. Do you have a question?
I'll jump in. Shenhao, great presentation. I know your work a little bit, but every time you present, I always learn something new. So thank you. And you might be able to expect this question. When you explain your analysis, the first part of your analysis on individual choice, I totally get it. And we always go back to theory and application, as Lisa said. So I could totally get the theory behind the individual choice when you incorporate the choice model with your image analysis. However, for your second part of the analysis, the 3D, the spatial temporal analysis, what I see, I might miss your point, but what I see is only kind of data analysis, the trend analysis, etc. Do you have theory behind your analysis? That's the first part. And the second still goes back to Lisa's question. What's the application? What's the impact after?
Yeah, thank you for the question. So the question is specific to the spatial temporal dynamics. One is what's the theory, what's the impact? So for my own work, the 2 or 3 slides I present, I use a deep learning. So spatial temporal deep learning model, mainly the graph neural network and the LSTM, those kind of temporal deep learning models. So whether they have theory, that's a very subtle question. From a network theory's perspective, they will tell me that there's no theory, zero theory behind those spatial temporal deep learning model. But if you just directly tell this, what I say to a computer scientist, they will be mad because I did that 6 years ago. They're like, it's a full of theory. Because whenever they talk about this kind of prediction task, they try to understand the generalizability of such prediction, or they try to understand the optimization property of such learning, this algorithm. So they will tell you, computer science will tell you there are a lot of theories about optimization, about statistics behind those models. But I understand what's missing there is some economic theory, those kind of interpretable theory we are more familiar with, which at least in the 3 slides I present, they still do not exist. Right. But whether it could exist in the future, that's a very good question. There are some emerging field called causal machine learning or causal deep learning. They try to embed some theoretical insights into this kind of complicated spatial temporal deep learning model. But it's still at a very early stage. I think there are people dedicated to this work, try to synergize this theory-driven and data-driven network analysis. But it is still at an early stage. In terms of social impact, that's also a good question. Actually, there are a lot of companies already use this model just in the industry. For example, what I presented, the spatial temporal deep learning model for travel demand prediction, that has been widely used for the mobility industry. Like Uber or Lyft, they try to use this model to capture what's exactly the next day's travel demand and where the ridership will come from, so that they could design their operation strategies, rebalance their vehicles to the right regions in the city. So this such work often involve a lot of collaboration on the industry side and then also the academia side. So I'm aware that this thing already happened in industry. But again, the spatial temporal dynamics is a very general perspective. It's really way beyond the mobility side, right? As I mentioned, it could be applied to energy, air pollution, or anything in urban setting. So I believe, at least from the prediction perspective, it can be widely used across a lot of industries.
Shenhao, I have a question for you. As it seems important across all of your lines of inquiry is really trying to build firewalls so that your research is equitable and inclusive. And you're looking at populations in Chicago, you're looking at populations in Singapore, and it would seem you're ready to take on the world. We know from research that implicit bias runs deep. and it's not always hard. It's not always easy to eradicate it. What is enough? What criteria are you using? At some point in the research, and perhaps you're doing it now, I'm not aware that you are, would you incorporate a research psychologist with expertise on implicit bias? Because it would seem as though there could be universal dimensions, but then also culturally specific dimensions of bias that you would want to address as you're building these models that are ultimately going to inform policy. But yeah, I'd be interested in your thoughts on this.
Yeah, thank you. That's a very deep question and involving many dimensions. I'm not sure I could answer this question very well. But in terms of, if we just look at the algorithm fairness, this new line of work which emerged in the past 5 years, I think one thing we could really learn from this research is that they try to provide the exact definition for fairness or justice in general, which actually think about it is very ambitious. And that they already made a lot of progress in defining clearly what justice or fairness mean in a mathematical form. And once you could success in that on that front, and then you could really do this kind of embed those algorithms into the real time like control operation things, and get a quantitative metric for the justice, which is kind of unimaginable like before we see such like those machine learning papers. So, and when we adopt this criteria, and they also actually pose a lot of problem because those criteria or the definitions always are not always compatible with each other. You need to resolve those conflicts in this all kinds of definitions. So this is one thing. I think there is some interesting progress, but there are a lot of unresolved problems. In terms of underlying all the implicit biases and the root causes of such biases, as I acknowledged in one slide, we still don't know. It could come from the data side, model side, or any source is possible. But there's one thing which I actually did not highlight in my presentation is regardless of such sources of biases, we could always adopt some machine learning approach to correct all those biases if we just look at the output from the model. Right? I mean, the data could contain bias, the machine could have some bias, but in the end, it's just the output, right? It's like how to balance the different like social resources, all the balance the different prediction accuracy. And then we could use the machine learning approach to maybe overcorrect the machine bias a little bit and deal with the human biases. Then in the end, the output from a model could be just fair, regardless of the definition of the fairness. So that's actually one interesting thing that maybe we cannot fully know all the root causes of this unfairness or the algorithm biases. But even we cannot achieve that, we could still correct the biases in maybe in the end could be very valuable to the practice.
Thank you. You did well with that question. Nick, do you have something to add? Anyone else with a comment or question for our presenter today? Well, you've given us so much to really think about and did such a wonderful job sort of laying out in words and frameworks, and I really applaud you on your visuals. They were just terrific to sort of capture what your research is really sort of the foundation that your research is sort of built on visually. I really loved seeing that. We're looking forward to our upcoming presentations. We definitely want to see you come back and bring your colleagues, bring your students who came. Really glad to see you here. Hope you get involved in the urban analytics program and continue to follow this great line of inquiry that's been developed by Shenhao. Upcoming, we have Nicholas Serino, really pleased and excited to hear about his research on landscape history and material culture and what he's been doing. Very excited to have him here. We'll be hearing from Jules Burke on some of her community-based and organized research in landscape architecture that's having tremendous environmental impacts. We'll be hearing from Cleary Larkin and some of her collaborators in historic preservation that are making great strides from St. Augustine to really outposts around the world. And then we're going to cap off our seminar series with some thoughts and discussion from our new director of the PhD program, Brian Franz. So thank you all for coming and have a great weekend. Take good care. Thanks again.